Okay everyone, it's time for 11.5 on differential equations. Now, this is something that you will do in university if you do a couple math courses, and it's pretty hard. Gosh, I don't know how much of it I remember, to tell the truth. It's been a long time since I took differential equations in university, but I do remember it's challenging. Now, luckily, it can start not too tough, and that's all we're going to do. It's all we have to do in Calculus 12, is just to give you the basics with differential equations. You can worry about the super hard ones when you get to your second year university or something like that. And many of you, to be honest, probably will never end up taking differential equations unless you're going into engineering or mathematics or physics or something like that. Alright, so what are differential equations? They're equations that contain a derivative. And they're very useful in real life scenarios, right? In science and business and things like that. Often differential equations can provide us with information that we need. And we solve them by finding the antiderivative, or the indefinite integral. So we're going to use a method which is called separation of equations. These are the most basic differential equations you can solve by using this method called separation of equations. That's all we're going to do this year, and that's how you'll start if you take differential equations at university. So basically, this is the method used to solve the most basic differential equations, and what you do is you move the different variables. You probably often have x's and y's. It doesn't have to be, but it often will be. You're going to move them to opposite sides of the equation, and then you're going to integrate both sides separately. You'll integrate one side with respects to x, you'll integrate the other side with respects to y. Okay, and what this is going to give you, for the first type of questions we do, is it's going to give you a family of solutions. In other words, it's a solution that contains a constant, or a plus c term. So you remember this before when we did indefinite integrals. You had to always slap a plus c on the end of your answer. And the reason for that is because the constant could be any number, right? So this is why it's a family of solutions, because when you get your answer, you're going to get one type of solution that describes an infinite number of solutions, actually. Each would have the same shape on a graph, right? Let's say that you get the answer, I don't know, let's just make it really easy. Let's say your answer was y equals x squared plus c. Well, if c is 0, you would just have this, right? This is y equals x squared. If c was 1, you'd have y equals x squared plus 1, which would look exactly the same, but would be moved up a bit. If c was negative 4, you'd have something that looks like this. Again, looks exactly the same, but it's moved downwards. So this is what I mean by they all have the same graph. You get an infinite number of solutions because of the plus c. Okay, so let's try solving a couple of these. So we have x squared minus 1 dy equals x dx over cosine y. So the idea here is you want to get the x's and the dx on one side, and the y's and the dy on the other. Okay, well let's look at our y's first of all. Do you see that I could move the cosine y over here? I could multiply both sides by cosine y, if you want to think of it that way. Multiply by cosine y, which would cancel out this, and multiply this side by cosine y as well, and you'd have your cosine y and your dy. But wait a minute, I want to get rid of this x squared minus 1. How am I going to do that? Well, by dividing both sides by x squared minus 1. That'll cancel out this, and of course I have to divide this side by x squared minus 1 as well. And we still have our x dx up here. So I hope that makes sense. I mean, probably you wouldn't write it this way, would you? By the time you get to Calculus 12, you'd probably just look and say, oh, I can move the cosine y up here, and I can move the x squared minus 1 down there, and I've done it. I've got all the y statements on this side, all the x's on that side. So now what we're going to do is we're going to integrate both sides. On the left-hand side, we're going to integrate in terms of y. So we're going to take the integral of cos y in terms of y. And on the right-hand side, we're going to integrate in terms of x. So we have x over x squared minus 1 dx. So again, we're kind of following our rules from grade 8. What you do to one side, you do to the other. We just happen to be integrating on both sides here. Okay, well this isn't hard. On the left-hand side, the integral of cosine y is sine y. So that's good. Now, the right-hand side is a little more difficult. I wish I'd given myself more room for that. Do you see what type of integration you might have to use here? I think u substitution might be the way to go. So what are we going to make equal u? Remember, we often make the denominator equal u, and that'll work in this case. If we make the denominator u, so x squared minus 1 is u, then du dx, when we take the derivative, will be equal to, the derivative of x squared is 2x, derivative of a constant is just 0, so this is what you get. But we want to end up with this x dx, right? We want to just have du here, and we want to just have x dx so we can replace it. So we'd like to get rid of that 2 on this side as well. Why don't we divide by 2? So you get du over 2. Alright, so let's continue writing here. I have the integral of, so our u, our x squared minus 1, that's in the bottom, right? Like this. And the top, our x dx, we're replacing x dx with du over 2. So du over 2, like that. Alright, again, I'm probably using more steps than you would do, but I want to make sure you understand. So this 2 is a constant. I can move it out front. Make sure you keep it in the denominator, though. So 1 over 2. So then all that's left is 1 over u du. And now we can easily take the derivative of the right-hand side. If you remember, this is one of the most common ones. 1/2. Do you remember what the derivative is of 1 over u? It's the natural logarithm of the absolute value of u. Now here's where we can finally put plus c. We could have written it right on the left-hand side, usually right on the right-hand side, but it doesn't actually matter. One last thing, u, we already had a statement for u. It's x squared minus 1, so we better write that in there again. Replace the u with our x squared minus 1. So 1/2 natural logarithm of x squared minus 1 plus c. Okay, then the last thing you do is you isolate your y. So this is sine y. What's the opposite of sine y? Inverse sine, or arc sine. I'm kind of into arc sine these days. Do you mind if I write arc sine? So you can either write arc sine and then in brackets everything I'm about to write, or I bet you at university you will use arc sine, by the way. I don't know why, but for some reason high school we tend to always say inverse sine like this, but in university it seems like most people learn arc sine. Either way works. And then what are you taking the inverse sine of? This entire side. Yes, you have to put all that in brackets. Maybe I'll go natural logarithm of the opposite value of x squared minus 1 divided by 2 plus c. Of course, you could just put 1/2 up front. Maybe that looks better. I don't know. Whatever your preference is, we have found the answer. Now, there's also situations, questions, where you have specific solutions, where you won't have the plus c. So this requires that you know at least one point of the differential equation's antiderivative. Oh my gosh. So you're often going to be given the initial value. In fact, I think in your textbook they call these the initial value problems. This is when t equals 0, right? When time is equal to 0. But basically the idea is they're going to give you 1 point. In the first question they're going to give you -1, 0 here. You're going to do everything we just did before, but then you're going to plug that in so you don't have to have the c. You can get an actual equation this time. So this one, find the curve y equals capital F of x that passes through this point and satisfies this differential equation right there. So that's the differential equation we're going to work with. And remember, what we want to do is we want to get the y by itself on one side and all the x's on the other. Well, that's easy. Just move the dx over. So I have dy equals 6x squared plus 6x dx. And we're ready to integrate right now. So we're going to integrate the left side in terms of y, and we're going to integrate the right side in terms of x, and we can go straight ahead and do that. What number is right here? 1. So when you integrate 1 in terms of y, you get y. Great! We've already got our y isolated. This is awesome. When we integrate this, 6x, 2 raises up to a 3 and divide by the same amount, plus 6x, the 1 goes to a 2 and divide by the same amount, plus c. Yes, you do put plus c, but you'll see we can get rid of that in a second. So let's simplify this. y equals 6 divided by 3 is 2x cubed plus 6 divided by 2 is 3x squared plus c. Okay, we still have that annoying plus c. I don't want that there. I want the exact equation. How do we do it? I look at this highlighted bit right here. I mean, of course you know that this is an x and this is a y. So let's plug those numbers, the negative 1 and the 0, into the x and the y. So instead of writing y, I'm writing 0 equals 2 times negative 1 cubed. Oh, I need more space. 3 times negative 1 squared plus c. See, we're going to figure out what c is. It's the only thing unknown here. So we can figure out what c is and then plug it in to this last red equation here. Let's keep going. 0 equals negative 1 cubed is negative 1 times 2 is negative 2. Negative 1 squared is 1 times 3 is 3 plus c. So 0 equals negative 2 plus 3 is 1 plus c. In other words, c is equal to negative 1. So you take this equation here and this information here and you plug that negative 1 into the c and you've got your final answer. Y equals 2x cubed plus 3x squared plus negative 1, but we just put minus 1. And we've done it. Okay, let's do one more. Solve the differential equation by separating the variables. Here's the differential equation, and here is our statement. Y of 1 equals negative 2. In other words, the point is 1, negative 2, right? There's our x, there's our y. We'll use that later. First of all, we're going to look at this, and we're going to get all the x's to one side and all the y's to the other. How are we going to do that? Well, first of all, I think I'll just move this over, this whole second fraction. So I have dy over dx equals, this moves over, 6x over y. Now, I could just multiply, basically cross multiply, right? Multiply both sides by y, and you get y dy. Multiply both sides by dx, you get 6x dx. And we're ready to integrate. So we're going to integrate y with respect to y. We're going to integrate 6x, although I could have moved the 6 out front, couldn't I? Because it's a constant. In terms of dx, we'll just do this. All right, what do? We take the 1, which is the exponent there, and raise it up and divide by the same amount. And on this side, we take the 1 here, raise it up to 2, divide by the same amount, and slap a plus c in there. Let's simplify. Nothing we can do here. Y squared over 2 equals 6 divided by 2 is 3x squared plus c. Okay, it's time to put our numbers in. We have a 1 for x and a negative 2 for y. I think I'm going to do it up here so I can still see it all. So where it says y, I'm putting negative 2. I have negative 2 all squared divided by 2 equals 3. And where it says x, I'm putting 1. 1 squared plus c. So negative 2 squared is 4, positive 4 divided by 2. So that's 2 equals 1 squared is 1 times 3 is 3 plus c. To get the c by itself, just subtract. So negative 1 equals c. So now I can plug this negative 1 into this c right there. So I get y squared over 2 equals 3x squared minus 1. Great. Last thing we have to do, we've got to isolate the y, get the y all by itself. So why don't we multiply by 2 on the right hand side, move this 2 over. So y squared equals 2 times all of this. You could just keep it like that, but I'm going to expand it through. So 6x squared minus 2, right, the distributive property. And now we have to do the opposite of squaring, which is square root. And remember, when you're solving equations, you have to put plus minus. So plus minus of the square root 6x squared minus 2. There you go. But wait a minute. Maybe we can be a little bit more specific than this. Maybe we can figure out whether it is positive or it is negative. Because remember, it goes through the point 1, negative 2, right? I wrote it right there, 1, negative 2. It goes through that point, 1, negative 2. So which one would it be? Would it be the plus or the minus? Well, let's see. I mean, it's pretty obvious, but let's just try it out. If you put 1 in here, 1 squared is 1, times 6 is 6, take away 2 is 4, and the square root of 4 is 2. Would it be plus or minus 2? Well, it says right here, minus 2. Obviously, it's only going to be the minus 1. So our final answer is y equals negative, not the positive one, the negative one, because it goes through 1, negative 2, negative 6x squared minus 2. That is it. Alright, I hope you don't get overconfident with your differential equations. That wasn't too bad, right? Oh, wait till your university class on them. Alright everyone, only one more video to go next day, and this calculus course is complete. Bye!